Good day, students. So in this clip, we're going to be going over two examples on how to graph sine and cosine curves on specified domains. So let's go ahead and write down the instruction for the notes. Graph the following functions on the specified domains. On the specified domains. Okay. All right. So for question number one, we're going to be graphing the function y equals 2 cosine x on the interval pi over 2 is less than or equal to x, and x is less than 2 pi. Okay? So first thing we're going to do is write this in standard form, find all the relevant components, and then graph. Okay? So in standard form, we can write this as y minus 0 equals 2 cosine factorial to 1 x minus 0. All right? Now this tells me that my new origin is going to be 0, comma 0. And that means that the phase shift is the x-coordinate of your new origin. There's no phase shift since this is just 0. And then the vertical shift is the y-coordinate of your new origin. The vertical shift is none also because there's no movement in that direction. Your amplitude is the absolute value of A. Okay, so what is A in this formulation that we have right here? This is K right here. This is A. This right here is B, and this letter right here is H. Alright? So absolute value of A is the same thing as absolute value of 2, because that's the coefficient of cosine. Absolute value of 2 is 2. So this is the displacement up and down from the central position. Alright? Okay, now let's put a period. The period is 2 pi over b. Alright? B is 1, so the period is going to be 2 pi over 1. So 2 pi over 1 is 2 pi. And this is going to be going, we're going to go 1 period to the right from the center and 1 period to the left, okay? For our points. And then when we're connecting dots, we're going to use this domain restriction to connect the dots, okay? Alright, frequency. The frequency is the reciprocal of the period, b over 2 pi, or the reciprocal of the period, which is going to be 1 over 2 pi. Okay? Alright, now let's set up our window to make sure that our graph fits in the allotted space. So our window will be set up as follows. From the center, which is 0, 0, I'm going to go up and down 2 units because that's my amplitude, okay? So I'm going to go up 2 units, and then I'm going to go down 2 units, okay? Side to side, I'm going to go by my period. I want 1 period to the left and 1 period to the right. So period is 2 pi, so plus 2 pi to the right, and minus 2 pi to the left, all right? So going up and down, 0 minus 2 is negative 2, 0 plus 2 is positive 2. That's my high, that's my low. To the right is going to be 2 pi, and to the left is going to be negative 2 pi. Alright? Okay, now let's set up our coordinate system. There goes my x-axis, and then my y-axis. Now for my x-axis calibration, our period is 2 pi, right? So let me indicate. That means that vortex is going to be 2 pi. Alright? Okay, so let's do that here. I'm going to let a box equal a tick. So we're going to have 1, 2, 3, 4. Okay? And that's 2 pi. And the first tick is pi over 2. Next tick is pi. Next tick is 3 pi over 2. Okay, the quadrantal angles. Alright, and then going to the left, 1, 2, 3, 4. That's a complete period, negative 2 pi. I don't need to put the values here because we're going to the right, okay? So max and min, let's just let 3 points be the max, the high point. The amplitude is 2. So if I go up, if I want this to be the max, I'll call that 2. And I'll go down 3 boxes and I'll call that negative 2. All right, so let's graph our max and min. This is our max right here. And then this is our minimum. Okay? All right, now let's go ahead and put in the dots. Remember the configuration of the dots. For sine, when you're graphing your sine, it's like one complete period is like an x. Okay? And then when you're graphing a cosine, one complete period is like a cot. Okay? So in this case, we're graphing a cosine, so it's going to look like this. Okay, so let's put our points in. So starting from the max, I'm going to go max, center, min, center, and then max. Okay? Now when connecting our dots, we need to restrict our connection to this region right here. So we start with this has a line here. This is a closed circle from pi over 2 all the way to 2 pi open circle because there's no line here, okay? So when we're connecting our dots, we have a closed circle here, right here, and we're going to have an open circle right here where it terminates at 2 pi, and then we'll just connect the dots, okay? So let's go ahead and connect the dots. We're starting from here, not there this time, so go straight out the center, curve out the min, curve out the min. So that's not good. Let's try that again. So we go straight out the center and then curve at the min, curve out the min, and then curve out the min, straight towards the center, straight out the center, and then curve at the max. Okay? So you notice that this piece is missing. So this is a closed circle right here, and then it goes like that. Okay? So that's the graph of your cosine function from negative 2 pi, from pi over 2 to 2 pi. Okay? So there you have it. All right. Let's go ahead and take a look at question number 2. So in question 2, we're graphing the function y equals negative 3 sine x on the interval negative pi over 2 all the way to pi. Okay? All right, so let's first express this in standard in transformational form. So it's y minus 0 equals negative 3 sine 1 times x minus 0. Okay? All right, so with this form, I know that this is my okay, this is A, this is B, and this right here is H. All right, so let's look for the new origin. My new origin is basically 0, 0. That tells me that the phase shift, which is a y coordinate, they're none. And then my vertical shift, none also. My amplitude, for the scalar quantity, there can be any signs there, is the absolute value of A, which is the absolute value of negative 3, and the absolute value of negative 3 is 3, because negative 3 is 3 units from 0. Okay? Alright, my period is given by the formula 2 pi over b. B is 1, so it's going to be 2 pi over 1, which is just 2 pi, and this goes in the left and right direction. Okay? And then amplitude goes up and down along the y. Frequency. What is our frequency going to be? Our frequency is b over 2 pi, or the reciprocal of our period, which is 1 over 2 pi. Okay? Alright, let's go ahead and set up the window so that we can know how to apportion sufficient space to our graph. So starting from 0, 0, we're going to go up and down 3 units. Okay? So plus 3 to the top, and then minus 3 to the bottom. Okay? So that means my high point is going to be 3, my low point is going to be negative 3. Side to side, we're going to use the period. So it's going to be plus 2 pi to the right, and negative 2 pi to the left. Okay? This is just for a period to the left and a period to the right, which is 2 pi to the right and negative 2 pi to the left. When we're connecting our dots, we're going to refer to this constraint right here, okay? All right, now that we have our window set up, you know, we just have a center, go 2 pi left, negative 2 pi to the left, negative 2 pi to the right, up 3 and down 3, and that will be the window of my graph, okay? So let's create that right here. So let me go to the y-axis, and then my x-axis. All right, so now let's calibrate. Since the period is 2 pi, that means that 4 ticks is going to be 2 pi. All right, so let's go ahead and do that here. So we're going to have, let me use 2 boxes per tick. 1, 2, 3, 4. That's going to be 2 pi. I know that this is pi, and we know what the rest are. This is pi over 2. And this is 3 pi over 2. Okay? And then going to the left, 1, 2, 3, 4. Now that's negative 2 pi. This is negative pi over 2. Okay, let me go up and see where we're starting from. In this problem, we're starting from negative pi over 2. Okay, so let's keep that in mind. Our amplitude is 3, so we're going to go 1, 2, 3. Our high point is going to be 3. And our low point from the center, 1, 2, 3, is going to be negative 3. Okay? All right, let's put our maximum in. This is our maximum right here. And this is our minimum. Now, let's put in the dots. We're graphing the sine this time. We know that the sine is like an S, okay? So we're going to graph it. Starting from the center, we're going to have center, max, center. I'm going to stop right there, okay? Why did we stop? Why did we stop there? Well, because we were supposed to go as far as pi, so we don't need any more points other than pi, okay? And then going back, we go that as far as negative pi over 2. And that's where we stop, okay? So is it going to be open circle and closed circle at the endpoints? Let's consult our interval notation. This is parentheses, so that means open circle and open circle, okay? At the end we have a bracket. This represents closed circle. And then the other bracket represents closed circle. Okay, so keep that in mind. Since these are parentheses, they're going to be open circle. All right, so our starting point and ending point are both open circles. So let's indicate that. So this right here is an open circle, and then our terminal point is also going to be an open circle. Okay, so this pi value right here is going to be an open circle. All right, let's go ahead and connect it. When we're doing our sine, we're just going to connect from here to here. So from the center, it goes straight, curve at the max, curve out the max, straight towards the center, and in the other direction, curve out at the min, and straight to the center like that. Okay, so there basically goes your sine curve from negative pi over 2 to pi. So thanks so much for taking the time to watch this video. You can feel free to subscribe to my channel just by clicking up here. More videos can be found on margaretserve.com. Thanks again and have a wonderful day.